Good morning to everyone. I am Mohan, Department of Mathematics, SNS College of Engineering. Today we are going to discuss about the orthogonal matrices. See, basically the mathematics will be a application. Then it will be a application. We need some restriction. That restriction we will get from the mathematics, because that restriction is using in the various places. So in that, here we are discuss about the matrices. In normally it is a matrices, row matrix, column matrix and square matrices. A lot of matrices are there. Now in this matrices, it will be a linear algebra with applications in field like geometry, physics and computer graphics. In this orthogonal matrix, see what do you mean by orthogonal matrix? In this orthogonal matrix is basically it will comes from repeated eigenvalues, and the matrices, it will be a symmetric matrix. See, the matrices will be a symmetric matrices and repeated eigenvalues, it will be comes a orthogonal matrices. Why we need that orthogonal matrices? See, in this matrix, orthogonal matrices, we know very well, A into A transpose is equal to A transpose into A is equal to I. That is the identical matrices. So in this orthogonal we need the very need into this orthogonal matrix. So in this, obviously the another way we know that the A inverse into A is equal to A inverse into A is equal to A into A inverse equal to I. But there is each and every matrices, there is a unique inverse matrices. So we need to find all the elements to the matrices. We need to find the inverse matrices. So everything will be different. So here the orthogonal matrices will be simplified that. So in this simplified matrices, that is a matrix will be a symmetric and repeated eigenvalues. Definitely it will come the orthogonal matrix. So in this orthogonal matrices we have to apply in the various places like linear algebra applications to the geometry, physics and computer graphics, and the transformations that prefers preserve distance and angles, then the range of importance applications, In these definitions and properties, see, in this orthogonal matrix, a square matrix is consolidated in the orthogonal if it is a transpose square to its inverse. See, basically in these matrices only it is possible to the square matrices. This property ensures that the matrices preserves length and angle when applied to vectors. See, that is the key properties. The determinant and orthogonal matrices is either 1 to 1 or minus 1. Then orthogonal matrices from the group under the matrices multiplication, The product of two orthogonal matrices is also a two orthogonal matrices. See, here we are given the examples, the matrices of cos theta, minus sin theta, sin theta, cos theta is a orthogonal for any angle theta. See, here the orthogonal matrices, here the every key point is a very important thing. There is a determinant of an orthogonal matrix is either 1 or minus 1. So here that the length and angles when applied to the vectors, then the matrix orthogonal matrix is either 1 or minus 1. Then here the value of in this existing the orthogonal matrices from a group under matrices multiplication is a very important thing, and the matrices multiplication. Then the product of two orthogonal matrices is also a orthogonal. That is the very important thing. See here the given the example of the cos theta comma minus sin theta comma cos theta. See here the orthogonal matrix is definitely the angle theta. The matrix represent a rotation in two dimensions. So it's very important thing. So in this orthogonal matrices, usually we are using in the various places, and the purpose of in this orthogonal matrices is to use the A transpose into A is equal to A into A transpose. That is the identical matrices. Then the matrix cos theta comma minus sin theta comma cos theta orthogonal for any angle theta. So here we are discussed about the definition and properties, but the in a mathematically the various places, the mathematically it's the various places we are using in the orthogonal matrices. Thank you.